Hi, my name is Katherine from Clemson University, and I've been working on WiMAX denial of service research, basically looking at the bandwidth contention resolution process and the system parameters that are used in that process and how they might be able to be manipulated to carry out denial of service attacks. This is different from your typical denial of service attack, which would include flooding or jamming, and the fact that it can go unnoticed. And so far in the past, we had a student who carried out software simulations using an NS2 simulator and looked at 3 different system parameters and found out that the client's setting of these system parameters can have a significant effect on throughput. And now we are currently taking it to the next phase and trying to recreate these experiments using actual hardware, using Orbit's facilities, and seeing if the system parameters will have the same effect when it comes to hardware in real WiMAX networks. We have so far carried out initial experiments where both attackers and clients use the same system parameters and have done an analysis on the indoor and outdoor WiMAX test beds of Orbit. And if you actually look here, that's what these results are showing. We were looking at back off start and back off end, and for our indoor environment, the second order interaction of these 2 parameters had a 42%, caused 42% of the variance in the throughput measurements. And this is a drastic difference compared to the outdoor environment where there was only 11% effect due to on the variance from these parameters. Both of the individual parameters, back off start and back off end, were insignificant according to our ANOVA analysis. And our next step then is going to be overriding the system parameters that the base station dictates so that we can have clients and our attackers having different system parameters. That's what we're kind of discussing here, is how we're going to do that. One option is the Linux file system, hoping that it's stored there within the file system. And another option would be modifying the WiMAX driver code. Both of these options we have taken initial steps in and are looking to see if we can find the system parameters now. Our initial Orbit experiments used the indoor test bed and the outdoor test bed. The resources on these test beds are both different, but we are using 8 nodes in each with 1 sync node and 1 base station. So here is basically a quick overview of what the indoor base station is. And then the outdoor base station is an actual WiMAX network with the nodes at different locations and distances from the base station on the Rutgers campus. We're looking at our denial of service attack simulations where we're going to have 3 attacker to client ratios used. The first one is if 20% of the nodes were client nodes, 20% are the attacker nodes, and then the other 80% are actual client nodes. And then we carried out simulations and software where we have 50% attacker nodes, 50% client nodes. And then the last option is 80% attacker nodes and 20% client nodes. Next, we're going to look at 2 of the system parameters, back off start and back off end, and show you an idea of what it would be like to change the back off start parameter for our client nodes. And in these video simulations, the idea is that our attacker nodes are keeping a constant setting on back off start, where our client nodes, we're varying the level of back off start. And then we're going to look at back off end in a video simulation here. And again, for back off end, the videos are trying to simulate if the attacker nodes are keeping a constant setting for back off end, and we're varying the level of back off end for our client nodes. And the concept behind these videos is trying to show what we believe the packet rate is how the packet rate's gonna be affected, what packets actually get through to the base station. And then from our software simulations and our hardware simulations, we have some initial results. For our NS2 simulator, we have frame duration and then the client's back off start basically being the major reason for the variance we've seen in our throughput measurements. Frame duration accounted for 23% of the variance, request retry 32%, and then back off start 5%. Those are both the client system parameters, not the attackers. And then in our hardware simulations, we have not yet simulated our attacker nodes, but we have done an analysis of the indoor and outdoor environments using back off start and back off end. And you can see that the second order interaction is significant in both of these environments. Though huge difference for indoor, the interaction accounted for 42% of the variance, where in outdoor, it only accounted for 11% of the variance. And another thing to note is the difference between the client's back off start and hardware simulation accounting for 5% of the variance, where in our initial hardware simulations, we're not seeing it be significant at all. So the importance of doing the actual hardware experiments is to see the difference between our software simulations and real networks in general, and as well as ideal networks compared to the more realistic outdoor wireless network. Oh, I think we'll just leave. So that's all for the video demo. So the importance of this work is to ideally see, one, if this kind of denial of service attack is possible, and second, we'll be able to hopefully provide recommendations on how these system parameters should be set. It's really just up to network administrators to come up with their own algorithms or methods for setting these system parameters, and there's not much guidance on what's best for the client. We hope that by the end of next spring, we should wrap up our hardware experiments and have analysis on the two system parameters we've been looking at. And the other real importance will be being able to compare the NS2 simulator, which is a full software simulation, and see how much the results from that compare with actual WiMAX networks, which will be an important thing to know.